In 1991, deep inside the pit lane at Le Mans, mechanics stood around a screaming orange and green race car that sounded nothing like its rivals. No deep V8 thunder, no exotic Italian howl, just a high-pitched mechanical shriek that sounded almost broken, like an engine tearing itself apart at 9,000 RPM. Most people watching thought it had no chance. 24 hours later, that strange little machine had done the impossible. It became the first Japanese car ever to win the 24 Hours of Le Mans. And under its hood sat something even crazier, a tiny 2.6-liter rotary engine with no pistons. No pistons. At the center of that victory was Mazda's legendary 13B Rotary. An engine so unique, so brilliant, and so controversial that even today, car enthusiasts still argue about it. Was it a masterpiece decades ahead of its time? Or was it an engineering dead end that nearly destroyed Mazda itself? Because what almost nobody realizes is that the 13B didn't just make Mazda famous. It also helped push the company into one of the biggest financial disasters in its history. And the deeper you look into the story, the crazier it gets. To understand the 13B, you have to go back to a time when Japan's car industry was still trying to prove itself to the world. The 1960s were brutal. American V8s ruled drag strips. European brands dominated motorsport. Japanese manufacturers were mostly known for cheap economy cars. Reliable, yes. Exciting? Not really. Toyota built practical sedans. Nissan focused on affordable transportation. Honda was still figuring out how to make cars instead of motorcycles. The Japanese badge on a sports car was almost laughable to Western enthusiasts. But Mazda wanted something different. They didn't have the money to outmuscle Ford or GM. They couldn't out-prestige Ferrari or Porsche. So instead, Mazda bet its future on one bizarre German invention created by engineer Felix Wankel. The rotary engine. Instead of pistons moving up and down, a rotary used a triangular rotor spinning inside an oval-shaped housing. Fewer moving parts, smaller size, higher RPM capability, smooth power delivery. On paper, it looked revolutionary. The simplicity was stunning when you actually looked at the design. Where a conventional four-cylinder engine needed dozens of major components, complex valve trains, heavy crankshafts, and precisely timed camshafts, the rotary accomplished the same four-stroke cycle with just a spinning rotor. Intake, compression, combustion, exhaust, all happening simultaneously in different chambers as the rotor turned. It seemed like magic. But there was a problem. Almost every company that experimented with rotaries gave up on them. NSU nearly collapsed because of reliability nightmares. Mercedes walked away. General Motors killed its rotary project before production. Even Citroën lost millions trying to make the design work. The engines burned oil. Apex seals failed. Fuel economy was terrible. Emissions were worse. Most companies saw the rotary as a mistake. Mazda saw opportunity, and that decision would define the company for decades. By the late 1970s, Mazda engineers had become obsessed with solving the rotary's biggest weaknesses. They experimented endlessly with housing coatings, seal materials, oil metering systems, intake geometry, and thermal expansion problems. Teams worked around the clock testing different apex seal compounds. They tried carbon. They tried various metal alloys. They experimented with coating the housing with chrome, aluminum silicate, and eventually nickel phosphorus compounds that could withstand the extreme heat cycles. Then came the engine that changed everything. The 13B. Introduced in 1974 and continuously evolved for decades, the 13B became the most famous rotary engine ever built. Technically, it was a 1.3-liter twin-rotor engine. Each rotor displaced 654 cc, giving a total displacement of 1,308 c. But rotary displacement numbers were always controversial, because a 13B absolutely did not perform like a normal 1.3-liter engine. Not even close. Early naturally aspirated versions produced around 135 horsepower. Later performance variants climbed to 160, then 200. then over 250 horsepower in factory turbocharged trim. And race versions? Those became monsters. The magic came from how the engine breathed. Unlike a piston engine with valves opening and closing, the Rotary's ports allowed almost continuous airflow at high RPM. The engine loved revs. It felt smooth where piston engines felt violent. There was no valve float to worry about at high RPM, no valve springs that could fatigue, no timing belt that could snap. The Rotary just kept spinning, building power in an almost linear curve that felt addictive to anyone who experienced it. And it was tiny. A complete 13B weighed roughly 250 pounds, smaller than many motorcycle engines. Mazda engineers could mount it farther back in the chassis for near-perfect weight distribution. That's what made cars like the RX-7 feel so different. Especially the FD-RX-7 launched in 1992. Even today, many enthusiasts consider it one of the best driving sports cars ever made. Under its hood sat the 13B Rotary, the world's first mass-produced sequential twin turbocharged rotary engine. And this thing was insane. The engine used a 80mm rotor width and a rotor radius equivalent to a 4.1-inch chamber sweep. Compression ratio sat around 9.01 in turbo form. Factory power output in Japan reached 255 horsepower due to the gentleman's agreement. In reality, many dyno tests showed closer to 280. Torque peaked around 217 lb-ft. That may not sound huge today, but remember, the engine itself was tiny. The sequential turbo system was unbelievably complex for the early 1990s. One turbo operated at low RPM for responsiveness. Then around 4,500 RPM, valves opened, vacuum actuators switched, and the second turbo came alive. That transition became legendary. Owners described it like getting kicked in the back by a motorcycle engine. The FD-RX-7 could hit 60 mph in around 5 seconds and run the quarter mile in the low 13s. Top speed exceeded 154 to unrestricted. But speed wasn't the most shocking part. The balance was. With the compact rotary pushed behind the front axle, the RX-7 achieved nearly 50-50 weight distribution. Steering felt telepathic. The car changed direction like a living thing. Automotive journalists who tested it came back stunned. Motor Trend compared it favorably to Porsche's costing twice as much. Road and Track called the handling supernatural. Some reviewers claimed it was the best balanced production sports car they'd ever driven. Then the tuners got involved, and things escalated fast. Because the 13B responded to modifications like almost nothing else. Larger turbos, street porting, bridge porting, peripheral ports, massive intercoolers, standalone ECUs. Suddenly these little engines were making 400 horsepower, then 600, then over 1,000. Tuning shops in Japan started building absolute monsters. Companies like Ari Amamiya, Rotary Engine Renewal, and Feed became legendary for coaxing insane power from the tiny twin rotor. Drag racers in Australia and New Zealand built rotaries that humiliated big block V8s. At full throttle, heavily modified 13Bs sounded less like cars and more like chainsaws fighting jet engines. But there was a darker side to all this, because the same design that made the Rotary brilliant also made it fragile, and eventually, the weaknesses became impossible to ignore. The biggest problem was heat. Rotary engines generated enormous combustion temperatures concentrated in tiny areas. Apex seals, the small metal strips sealing the rotor tips against the housing, lived a brutal life. If oiling failed even briefly, the seals wore rapidly. The geometry made everything worse. Because the combustion chamber was long and narrow, peak temperatures concentrated at specific points on the housing. Those hotspots caused uneven thermal expansion. Seals had to maintain contact across surfaces that were literally warping from heat in real time. When that happened, compression disappeared. And then the nightmare started. Owners described cold start issues, flooding, excessive oil consumption, misfires, hard starts, carbon buildup, premature wear. Some engines needed rebuilds before 60,000 miles. Mechanics would pull apart failed 13Bs and find scorched housings, chipped seals, and oil systems full of metallic debris. One former Mazda technician reportedly joked, "A Rotary either runs perfectly or it's completely dead." There wasn't much middle ground. And fuel economy? Absolutely terrible. A turbo RX-7 could easily average 14 to 16 miles per gallon under spirited driving. Some heavily modified cars dropped into single digits. The problem was fundamental. The long, narrow combustion chamber made complete fuel burning nearly impossible. Unburned hydrocarbons went straight out the exhaust. That meant wasted energy and terrible efficiency. That became a disaster in the real world, especially during tightening emissions regulations in the 1970s and again in the 1990s. See, rotaries naturally struggled with incomplete combustion. The long combustion chamber shape made it difficult to burn fuel cleanly. Hydrocarbon emissions were notoriously high. Mazda engineers fought constantly against physics itself. They added thermal reactors, air injection systems, catalytic converters, more sophisticated ECUs, revised port timing. But every solution added complexity and cost. By the early 1970s, Mazda had bet so heavily on rotary technology that the oil crisis nearly wiped the company out. Suddenly, fuel economy mattered more than performance. Consumers panicked. Sales collapsed. Rotary-powered cars became difficult to sell overnight. Mazda reportedly lost massive amounts of money trying to survive that period. Dealerships were stuck with inventory nobody wanted. Production lines sat idle. Financial analysts predicted bankruptcy. The Sumitomo Bank had to step in with emergency loans just to keep Mazda alive. Company executives considered abandoning the rotary completely and focusing exclusively on conventional piston engines like every other manufacturer. And yet, they refused to abandon the rotary. Most people don't realize how stubborn Mazda really was. Other companies would have killed the project immediately. Mazda doubled down. That stubbornness eventually led to one of the greatest moments in motorsport history. The 1991 24 Hours of Le Mans. Mazda arrived with the 787B prototype, powered by the R26B Rotary engine. Essentially, the ultimate evolution of everything learned from the 13B program. 4 rotors, variable intake geometry, peripheral ports, around 700 horsepower at nearly 9,000 RPM. The sound alone became legendary. Drivers said it felt almost electric in how smoothly it delivered power. No heavy reciprocating parts, no violent vibration, just endless RPM. But reliability was the real shock. See, endurance racing destroys engines. At Le Mans, cars run flat out for 24 straight hours. Temperatures explode, oil breaks down, components fatigue, and historically, rotaries weren't exactly trusted for durability. But Mazda engineers understood something crucial. The rotary simplicity also had advantages. No connecting rods, no valve springs, no timing chains, fewer catastrophic reciprocating failures. So while rivals suffered mechanical disasters, the screaming orange Mazda kept going, hour after hour, through rain, through darkness. Through exhaustion, driver Johnny Herbert later described the car as physically brutal to drive because of cabin heat and noise. The exhaust temperatures were extreme. The cockpit became unbearable. Volker Weidler and Bertrand Gachot, the other 2 drivers, reported similar experiences. The heat radiating from the engine bay was so intense that drivers would emerge from stints drenched in sweat, nearly delirious from dehydration. But the engine survived. At the finish line, the Mazda 787B completed 362 laps, over 3,000 miles. Average speed exceeded 127 mph. And for the first time ever, a Japanese manufacturer won Le Mans outright. The team erupted. Mazda executives who had flown in from Hiroshima couldn't believe what they were witnessing. Decades of research, millions of dollars invested, countless failures, endless criticism from competitors and media alike, all vindicated in one perfect race. It should have changed everything. Instead, it became the beginning of the end, because shortly after Mazda's victory, rule changes effectively eliminated rotaries from top-level endurance racing. New regulations favored conventional piston engines aligned with Formula One technology. The Rotary was pushed out just like that. Many suspected the rule changes were political. A Japanese manufacturer using unconventional technology had embarrassed European powerhouses. Whether intentional or coincidental, the new regulations made rotary competition essentially impossible at the highest level. And on the road car side, things weren't much better. The FD RX-7 became an icon, but it was expensive to build and difficult to certify under tightening emissions laws. Insurance costs skyrocketed. Reliability concerns scared buyers away. By 2002, RX-7 production ended. For many people, it looked like the Rotary era was over. But Mazda still wasn't done. In 2003, they launched the RX-8 with the Renesis rotary engine, another evolution of the 13B architecture. This version used side exhaust ports instead of peripheral exhaust ports to reduce overlap and improve emissions. Compression ratios ranged from 10.01 to 10.5.1 depending on transmission choice. Power outputs reached 238 horsepower naturally aspirated, and it could rev to 9,000 RPM. Again, from a naturally aspirated 1.3 liter. That was absurd. The RX-8 handled beautifully. Journalists loved it. The chassis was balanced, sharp, and forgiving. The suicide doors made it practical. The interior was surprisingly spacious. Mazda had created a legitimate four-seater sports car that could rev like a motorcycle. But the same old problems returned. Oil consumption, flooding, apex seal wear, weak low-end torque, poor fuel economy, and then came stricter emission standards. By 2012, Mazda finally ended production of the rotary-powered RX-8. For the first time in decades, there was no rotary sports car in Mazda showrooms. It felt like the dream had died. But here's the strange part. The Rotary somehow became more legendary after disappearing, maybe because it was flawed. Maybe because it demanded commitment. You didn't just own a Rotary, you lived with it. You learned its quirks. You pre-mixed oil into fuel. You warmed it carefully. You listened obsessively for compression loss and detonation. Owners became mechanics by necessity. They learned how to compression test their engines. They understood oil metering pump operation. They knew the sound of healthy apex seals versus failing ones. It became a cult. Today, clean FD RX-7s regularly sell for over $100,000. Rare Spirit R models in Japan can exceed $200,000. Tuners still chase four-digit horsepower builds from engines smaller than many lawnmower motors. And every few years, rumors return. Mazda is bringing the Rotary back. The company has already experimented with rotary range extenders for EVs. Engineers continue researching hydrogen-burning rotary concepts because the design naturally suits gaseous fuels. So maybe the story isn't over yet. But the bigger question still remains. Was the 13B genius, or was it a mistake? The honest answer is probably both. From a pure engineering perspective, the Rotary solved problems conventional engines couldn't. It delivered incredible smoothness, compact packaging, high RPM capability, and astonishing power density. But it also fought constant battles against thermodynamics, sealing, fuel efficiency, and emissions regulations. The laws of physics simply didn't favor the long, narrow combustion chamber design. No amount of engineering brilliance could completely overcome those fundamental challenges. In other words, the Rotary was brilliant and fundamentally compromised at the same time. That's what makes the story so fascinating. The 13B Rotary didn't dominate because it was perfect. It became legendary because Mazda kept chasing an impossible dream long after everyone else gave up. And somehow, against all odds, that impossible little engine won Le Mans, not with brute force, not with giant displacement, but with noise, obsession, and pure engineering stubbornness. That's why people still talk about it today, because the 13B wasn't just an engine. It was a rebellion against conventional thinking. If you enjoyed this deep dive, let me know in the comments what story you want next. Another forgotten engine, another racing rivalry, or another engineering masterpiece that changed car history forever. And make sure to subscribe so you don't miss the next one.